So also, all right. So let's start with this paper then today. Summer 23, paper 22. Question number 1. Forces of 3 and 4 Newton act at right angles is shown. What is the resultant force? Now you might also choose to basically swap around one of these forces just for you to see, but anybody who's done a lot of practice can identify this very easily, what the direction of the resultant should be. So here this 3 Newton force I've picked up and moved to another point, but it's still vertical. And now the head to tail rule is being obeyed, so this is how my resultant is, right? This being the right angle. So using Pythagoras theorem, I can figure out the resultant from O-level maths. This is also a common right angle triangle that you must know anyway. 3, 4, and the longest side, the hypotenuse is 5. And you can look at the direction, this is along OY. So C is the answer to this first question. A light ball is held at rest at the top of a tall cliff. It is released and falls through the air, eventually reaching its terminal velocity. Which row describes the behavior of the ball as it descends? Initial acceleration is because of its weight. So if that's the only force acting, it accelerates with acceleration due to gravity. And when the forces become balanced, acceleration becomes 0 and terminal velocity is reached. So the answer to this one is C. Again, these are not really all that difficult questions. Also, these questions have appeared in the previous sessions as well. This is not an entirely new question. Question number 3, the graph represents the motion of a car. How far has the car moved between 0 and 5 seconds? So this is a speed time graph, right? So the distance is the area under the graph. So all of this is what we want, right? All of this area, which is the area of a triangle. So I just use half into base into height. So half into 5 into 10. So 50 over 2, which is 25 meters. Question number 4, which statement about mass or weight is not correct? Masses can be compared using a balance. This is correct, so it cannot be the answer. Mass is a force. This is not correct. Weight is a force. So this is the answer here. Weights can also be compared using balances, and weight is a force. A sphere P made of steel has a weight of 10 newtons on Earth. Another sphere Q, also made of steel, has a weight of 10 Newton on Mars. So 10 Newton on Earth, 10 Newton on Mars. Small g on Earth is greater than small g on Mars. So if I think about this, I should immediately be thinking of this equation, W equals mg. So if I'm talking about Earth here, or Mars by the way, both of these have weights 10 Newton. So the weight is not changing. If the gravitational field strength on Earth is larger, this means that this thing that I'm talking about on Earth, that is supposed to have a smaller mass, and vice versa for the case of Mars. If gravitational field strength on Mars is less, this means that its mass is more. All right? So the one on Earth is P, the one on Mars is Q. Which statement is correct? The mass of P is the same as the mass of Q. This is obviously wrong, right? If the masses were the same and the gravitational field strengths were different, then the weights would also be different, but that's not the case here. The mass of sphere P is less than the mass of sphere Q. According to the reasons we just discussed, this is absolutely correct. Because they have the same weight and because gravitational field strength on Earth is greater, the mass of this sphere on Earth is less, right? On Mars, the weight of sphere P is the same as the weight of sphere Q. No, this is also wrong. On sphere Q, if it has a weight of 10 newtons, this is 10 Newton on Earth. So there is a difference in masses. If I take this same sphere to Mars, it would weigh something different. So this is also out. On Earth, the weight of sphere Q is less than 10. Again, this is wrong because we just discussed this, that Q has a greater mass. So when I take it on Earth, which also has a greater gravitational field strength. So mass is also greater, g is also greater, so it would definitely be more than 10. So that's why this is also out. So B is the correct answer here. Which two quantities must be known to determine density? So mass and volume, easy. Option B. 7. A truck is towing a car along a straight horizontal road at constant speed. So constant speed means forces are balanced. The rope breaks. Which row gives the direction of the initial acceleration of the truck after the rope breaks and the reason for the acceleration? So this car is just being towed, right? This engine of the car is not active right now. So what's really doing all the effective work here is the truck. So if this rope breaks, what the truck is doing right now is that it's exerting a force. Its engine is exerting a force which is making them move along the road. And previously what was happening is that that force was being shared between the masses of the car and the truck. Now that same force is only going to pull the truck, right? So if I think about this now, the same force, mass goes down, so obviously acceleration goes up, and the force was in this direction, so the acceleration would also be in that same direction. So direction of acceleration of the truck is to the right, and the reason the driving force is greater than the resistive forces, that's how it will accelerate. If the resistive forces are more, it would decelerate, right? And in that case, the acceleration would be to the left. So the answer to this one is C. All right, question number 8. A uniform beam is pivoted at the center and two identical masses x and y are placed so that the beam balances. A smaller mass is then added at the position shown. How can the masses be positioned so that the beam balances again? So if they were previously balanced, this means that there was no net moment. So the clockwise moment, because of its weight, equaled the anti-clockwise moment here. But now there's another anti-clockwise moment. So either I must decrease the anti-clockwise moment or I must increase the clockwise moment. Moving x away from the pivot means that the distance is now increased so that the anti-clockwise moment would increase. That's not what I want here, right? I want either the anti-clockwise moment to go down or the clockwise moment to go up. So that balance is achieved again. So moving x towards the pivot, this obviously must be correct because moving x closer to the pivot reduces the distance from the pivot, which makes the anti-clockwise moment go down. Moving y towards the pivot means the clockwise moment goes down because the distance goes down, so this is wrong. And moving the small mass away from the pivot again increases the anti-clockwise moment, which is not what we want here, right? So the answer to this one is B. Question number 9. A resultant force of 2 Newton acts on a object of mass 3 kg for 6 seconds. What is the change in velocity of the object? So we can use F equals to ma, but somebody could also choose to use F equals delta P over delta T, and it would yield the same answer. After all, the equations are numerically and also algebraically equal. So F equals ma, and instead of a, if I write this as v minus u over t, and v minus u, that change in velocity is what I really need. So F is, alright, there's also an m here, right? So F is 2, m is 3, v minus u is what I want, and t is 6, right? So 3, 2 times 2, v minus u is 4. Easy. Let's go on to another one. 10. The diagram shows the energy stores for a mobile phone and how the energy is transferred between the stores. So chemical energy becomes internal and kinetic energy, and it produces heating and sound. What describes how the chemical energy is transferred? So the chemical energy is basically the energy in the battery of the phone, and how that turns into either of these, internal energy and kinetic energy, is basically by that energy in the battery due to some electrical process being converted into this form, right? So that's electrical work done, right? That flow of current basically leads to electrical work done. All right, so we're done with a quarter of the paper. Question number 11. A wind turbine is 30% efficient, has an output of 2.5 megawatts. What is the power input? So efficiency is output over input. So 0.3 is output over input. So just 2.5 over 0.3. So that's 8.33. So B is my answer here. Question number 2. Which two physical quantities must be used to calculate the power developed by a student running up a flight of stairs? So power needs energy and time. So I definitely need time. So it can't be this, can't be this. So it must be work done, not force. I also additionally need either the work or the energy. So work done and time. Density of seawater is given, small g is given, atmospheric pressure is given. At which depth is the total pressure equal to this? So if the total pressure is equal to this, remember total means that atmospheric pressure is also to be added. So 513,000 being the total, subtracting this atmospheric pressure just gives me the liquid pressure rho gh. Rho is 1030, g is 9.8, and h is the depth which I need to find. So just calculating this. So this turns out to be 40.8, hence option A. 4 students described the phrase absolute zero during a lesson on the particle model. Which student is correct? This is the lowest possible temperature. This is, by the way, correct, right? This is correct. Particles in a solid start vibrating. This is not true, right? Particles in a solid are vibrating. It's not in terms of starting vibrating. It's more like this vibration never goes away. Even at this point, when we talk about the kinetic energy of particles, we don't say it's zero kinetic energy. We say it's the minimum possible kinetic energy. So it's not like they start vibrating here. Particles do not have any weight. Again, this does not make any sense at all. Particles have the least gravitational potential energy. Also does not make any sense, right? It's the point where the particles have minimum kinetic energy, right? Because of their vibrations. 4 students are asked to state and explain the relative magnitudes of thermal expansions of solids, liquids, and gases. Which student is correct? You know for a fact that between solids and gases expand more because there are less intermolecular forces, right? So it's easier to do work against those intermolecular forces. So gases expand more, obviously. So not this or this, because attractive forces between molecules are much weaker in gases. 16. 4 cups A, B, C, and D contain hot coffee. Which cup keeps the coffee warm the longest? Again, let's just think about the cup of coffee and what you want to do with it. So the idea is this, that if you have this cup of coffee, so there is this hot liquid inside this cup. Now this hot liquid is already inside, so this means that radiation will be going out of this cup. To keep it warm the longest, you need something which is going to reflect the radiation back in, and it will not let that escape, right? So the outside surface of the cup and the top of the cup. So covered with a lid, obviously, right? To keep it warm the longest, to reduce evaporation. And the outside surface of the cup, what should it be here? So to reflect that outgoing radiation, there must be a good reflector, so a shiny white surface is what we're going for. 17, the diagram shows a wave. What are the amplitude and the wavelength of this wave? So amplitude is pretty easy to see. This is just 3. From the mean position to the trough, to the crest or to the trough, By symmetry, both of these will be equal. So 3 and 3. And wavelength is going to be the peak to peak, or the trough to trough, or the start of one wave to the start of another wave distance, which is 8. However you want to look at it. Optical fibers are used to transmit digital signals using infrared. Average refractive index of fibers is 1.5. Which row describes a digital signal and gives the speed of infrared radiation? So digital means only two values. Again, this is IGCSE only stuff. It's not for O-level students. So only two values. And if we think about the other one, which is the speed of infrared radiation, so now you need to use this formula, that N equals to C over V. So N is 1.5, C is the speed of light, 3.0 into 10 to the 8. So you will calculate V, it will turn out to be 2 into 10 to the 8. So that's A. 19. Which statement describes monochromatic light? Monochrome means one color, means one frequency. And according to the same line of reasoning, also one wavelength. Beam of light consists of yellow and blue light. The beam of light is incident on a glass prism. Which diagram is correct? So if I just write down this mnemonic. So Vibgyor, red is the largest wavelength. It also bends the least, right? Red bends the least, violet bends the most. So we are comparing blue and yellow here. So blue is supposed to bend more, yellow is supposed to bend less. So it's, even ignoring this fact, it looks like either of these. Definitely does not look like this, because in going from less dense to more dense, it bends. If I just make the normal here, so it would bend towards the normal, not away, which is why both of these are wrong. And then out of both of these, the blue is supposed to bend more than the yellow, so it's D, right? Blue has to have more angle of deviation. A radio station broadcasts a signal with a frequency of 89 megahertz. What is the wavelength? So V equals to F lambda, 3.0 into 10 to the 8. F is 89, mega means 10 to the 6, and there's the lambda here. So we just need to make that the subject. So lambda turns out to be 3.37, 3.4. Oh, it's yeah. So it's 3.4 meters just. It's B. A boy shouts and hears the echo from a tall building. 2.2 seconds later, speed of sound in air is 330. How far away from the boy is the building? So speed equals to 2d over t for echoes, because this wave travels that distance twice. So speed is 330. 2d over time is 2.2. So 330 times 2.2 divided by 2 is 363 meters. So 360, correct to 2SF. Question 23. The magnetic field of a bar magnet can be represented by magnetic field lines. Which diagram shows two magnetic field lines correctly? So it must be going out from the north and coming into the south. So that's obviously A. That's how field lines are drawn. A plastic rod is rubbed with a dry cloth. The rod becomes positively charged. Again, read between the lines. This means that if the rod becomes positively charged, the cloth becomes negatively charged, right? So the cloth gains electrons, the rod loses electrons. So the rod has lost electrons. Which statement about electric current in a conductor is correct? In a DC circuit, the electric current gradually decreases along the conductor. Not true. Current is the same. In a DC circuit, the free electrons flow back and forth. Not true. This is for AC circuits. In an AC circuit, the electric current remains exactly the same at all time. Not true again, right? In an AC circuit, the electric current magnitude also changes and its direction also changes. By default, D must be correct, which it is, that the flow of charge changes direction continually. So it's going in one direction first and then it switches its direction. 26. A piece of metal wire X with a uniform diameter has resistance R. Second piece of wire Y is made of the same metal, has uniform diameter. Y has double the cross-sectional area, half the length. What is the resistance of Y? So resistance is proportional to length over area. So halving the length causes the resistance to halve. And doubling the cross-sectional area also causes it to halve, right? It's directly proportional to length, inversely proportional to area. So area doubles, resistance halves. So half and half makes it 1/4. So it's A in this case. 27. An electric fire is connected to a 240 volt supply and transfers energy at a rate of 1 kilowatt. How much charge passes through the fire in 1 hour? All right. So charge passing in 1 hour. So I have V, I have power. So P equals to VI. I can find out the current. Let's first do that. So P equals to VI. So 1000 equals to 240I. So this means I is 1000 over 240. So 4.167 amperes. And current is the rate of flow of charge. So that's delta Q over delta T. This time is in hours, but keeping everything in SI units, the time should also be in seconds. So I need to convert this then. So 4.167, each hour has 60 minutes. Each of those minutes has 60 seconds. So just multiply this by 3600. Turns out to be 15,000. So 1.5 into 10 to the 4 coulombs. Two lamps are connected in parallel. So there are these two lamps. Which switches must be closed so that both lamps light? So for this and this to light up. Now obviously this one must be closed, right? So any option that does not have S3 is wrong. So A is wrong. Yeah, A is wrong. Because S3 needs to be closed so that current flows into this loop. And S1 and S2, if you think about it, they must also be closed for there to be a complete loop so that current goes through the bottom lamp. So S1, S2, S3, all of these need to be closed. All right. 29. The diagram shows a circuit that switches on a lamp when there is a change in the environment. Which change in the environment causes the lamp to be switched on? Right, so this is the circuit diagram for a relay, by the way. If you guys did not identify, this is the relay. So what change causes the lamp to be switched on? So for the lamp to be switched on, this switch must be closed, and that will happen when there is a sufficient amount of voltage across this relay. For this, I would want the voltage across this to go up, but again, this is a fixed resistor. The voltage across it will not change by itself. It will change when, according to voltage division, this will go down, because the potential difference of this and the potential difference of this will always equal to the EMF. So for this voltage to go up, this voltage has to go down, right? So if I have a decrease in voltage, this also means that the resistance must go down. This is a thermistor. Resistance goes down when temperature goes up. That's T, right? 30. A step-down transformer is 100% efficient. It has an input voltage of 240, output of 60. Current in the primary coil is 0.5. What is the current in the secondary coil? So if it's 100% efficient, this means there is no power loss. So power in equals power out. Power in is VI, V input, I input. So input current is 0.5 in the primary, and output is 60 times this current that I want to find out, right? So 240 times 5, 120 over 60 is 2. The diagram shows the pattern of the magnetic field due to a current I in a straight wire. Which row is correct? So direction of field. Alright, so this is current into this plane of the page. So if I just curl this around, so I will see that Y is correct, right? That's how the current is supposed to go. So it's Y. And field is greater at P or Q, so it's definitely greater at Q because the field lines are closer together there. So 31 is D. 32, in which device is the magnetic effect of a current not used? It's used in an electromagnet, it's used in a loudspeaker, it's used in a relay as well. It's not used in the potential divider, right? It's used in all of the others. Fission and fusion are two types of nuclear processes. How does the total mass of nuclides compare with the total mass of the original nuclide or nuclides in these nuclear processes? So total mass of fission products compared to original nuclide, total mass of fusion products compared to original nuclides. So in fission, what happens is you have something breaking up into basically into smaller nuclei, right? So in fission, the mass is less of the products as compared to the nuclei because it's simply breaking up. But the idea is that if I'm also talking about fusion, then the total mass of the products is less than the, alright, let me place ticks here. So the total mass of fission products is also less. Total mass of fusion products is also less. This is again something which is more assessed in IGCSE. The idea has to do with this, that a reaction will spontaneously go forward. It would release energy when there is what we call a mass defect. There needs to be a decrease in the mass. So what this means is that the mass of the reactants, or let's say the mass of the products, has to be less than the mass of the reactants. For any equation, for any nuclear process to take place, this must be true, right? Be it fission or be it fusion. So this is the idea of mass defect. This is what must always be true. All right. So yeah. 34, the table shows the composition of 3 different nuclei. You have number of protons, number of neutrons, which are isotopes. So same number of protons, obviously. So X and Y only. Pretty easy. Next, which change occurs in the nucleus of a radioactive atom during beta emission? So again, it's a neutron-proton transformation. It has nothing to do with an electron. Again, I've forgotten what it actually was, so I'll work it out again. It's also going to refresh your memory. So I have an electron being released. So 0 minus 1. So it has to be a proton here. So 1, 1, and it has to be a neutron here. So that in going from here to here, the proton number increases by 1, right? It obviously can't be a 2 here because it could only be a neutron or a proton inside the nucleus. So neutron to a proton, that's B. 36, a radioactive isotope has a half-life of 8 days. A detector close to a sample of this isotope gives a count rate of 200 counts per minute. Without the source, the background radiation is 20 counts per minute. What is the count rate due to the source after 8 days? So 8 days means just one half-life. Out of this 200, 20 is the background, So this means that the actual thing of interest to me is 200 minus 20, which is 180. And after one half-life, this 180 will fall to half of it. It would be 90, but there would be the background count again. So 90 plus 20 makes it 110. Which statement about the solar system is correct? All the planets are rocky. Wrong. The closest 4 are rocky. The other 4 which are further out are gaseous. Only the Earth has a moon. Again, wrong. All planets have moons. Only Earth is the one which has only one moon. Other planets also have more moons. Pluto is a dwarf planet. Alright, just a sec. Yeah, Pluto is a dwarf planet. This is true. Pluto is classified as a dwarf planet. There are many stars in the solar system. Tempting, but this is wrong. There is only one star, which is the sun. Right? 38. Comets are bodies which orbit the sun in the solar system. What is the shape of the orbit and how is the sun positioned within the orbit? So comets are there. I taught you guys some differences between comets and asteroids. There are some differences in terms of their structures, in terms of their orbits and shapes and their frequency of orbit. So the most important thing is that they do have elliptical orbits. And if you think about the orbit, in this case, the sun is not at the center because it's an ellipse. It's not like a circle. There is no one center. There are two foci. There are two focuses basically. So sun is not at the center of the orbit. That's the bottom line. So it's D. All right. 39. Which nuclear reaction produces the release of energy to power a star? So fusion of hydrogen to helium, D. And the last one, what is the definition of the Hubble constant? Again, we've done this. It's D equals to, alright, I'm forgetting here. Yeah, V equals to H naught D, right? So H naught is V over D, so it's the ratio of the speed at which the galaxy is receding towards distance from the Earth. The value of the change in wavelength is just known as the redshift. The constant used to represent the rate of expansion, again, doesn't really apply here. Estimated constant equal to the age of the universe, that's 1 over Hubble's constant. So that's that. Again, it's a definition. So even though this one does make sort of sense, rate of expansion in all directions, but it's not the definition. The definition is in terms of this ratio.